So, you've probably heard the term neural network thrown around a ton, right? It's the powerhouse behind things like ChatGPT, self driving cars, basically, all the AI that's changing our world. But what is it really? Okay, let's break it all down and see how these things actually work from the very beginning. It all really boils down to this one simple but kind of mind blowing question. What if a computer could learn not by following a bunch of rigid, pre programmed rules, but by just observing, making mistakes, and getting better over time, just like we do? That single idea, that's the key to everything we're going to talk about.
To really understand the artificial version, we first have to look at the OG inspiration. The entire concept of a neural network is basically a copy of the most amazing learning machine on the planet, the human brain.
See, inside your brain right now, there are billions of these little things called neurons. And you can think of each one as a tiny, tiny decision maker. It just sits there, listens to signals coming in from its neighbors, decides if the total message is important enough, and if it is, bam, it fires off a signal of its own. That's it, a simple process repeated billions of times. And when we built the artificial version, we pretty much copied that blueprint directly. In a biological neuron, you've got dendrites that act like antennas, receiving signals. Well, in our artificial neuron, we just call those inputs. The cell body chews on those signals, our node does the exact same thing. And when it's time to send a message out, the axon carries it, just like the output from our digital version. It's a really elegant one-to-one parallel.
All right, so let's zoom in on just one of those artificial neurons. Let's really break down how this single, simple little thing actually, well, thinks. It's basically a three-step dance. First, it gets a whole bunch of inputs, just pieces of data. But here's the crucial part in step 2. Not all that data matters equally. So the neuron weighs each input. Just think of these weights as little volume dials. Some inputs are turned way, way up because they're important, and others are barely a whisper. Then, for step 3, it just adds up all that weighted info. If the total signal is loud enough to cross a certain threshold, it fires. If not, it stays silent. Simple as that.
So that big question, is the signal strong enough, is answered by something with a fancy name, an activation function. But don't let the name scare you. All it does is take that messy, combined signal and make a final, clean decision. It boils everything down to a simple yes or no, a 1 or a 0. That's its entire job. Okay, so one neuron on its own is, well, it's just a simple switch. Kind of boring. But what happens when you start connecting millions or even billions of them together in organized layers? Oh, that is when things get really interesting. Everything kicks off at the input layer. Its only job is to take in the raw, messy data from the outside world. So if you're feeding it a picture of a cat, this layer doesn't see a cat. It just sees a giant grid of numbers representing the color of each and every pixel. Next up are the hidden layers, and honestly, this is where all the magic is. The first hidden layer might look at those raw pixels and learn to spot really simple things, like diagonal lines or bright spots or corners. Then, the next layer takes those lines and corners as its input and learns to recognize more complex shapes, like circles, or maybe something that looks like an ear or a whisker. Each layer builds on the last, finding more and more abstract patterns that we would never see in the raw data. And finally, after all that processing, we get to the output layer. This layer takes all those high-level features the hidden layers found, whiskers, pointy ears, fur patterns, and puts it all together to make one final call. Its output is the simple answer that we can actually use. Something like, yep, 98% chance this is a cat. Whenever you hear that buzzword, deep learning, this is all it really means. It's just a neural network that has a lot of these hidden layers stacked one after another. The deep part is literally just talking about the depth of those layers, and it's what gives these networks the incredible power to learn super complex, subtle patterns. So we have the whole structure set up. But wait a minute. How does the network know which of those millions of little volume dials to turn up or down? How does it actually learn to get things right? This right here is the most brilliant part of the whole thing. It all happens through a process called training. And what's wild is we don't program it with rules. We don't tell it, if it has whiskers and pointy ears, it's a cat. Nope. We just show it millions of examples over and over. And for each one, we just say, this one, cat. This one, not a cat. And the learning works in this constant loop. First, the network sees a new picture and makes a guess. Let's say a guess is dog, but the picture is actually a cat.
Step 2, we compare its guess to the truth. We calculate the error, basically how wrong it was. Then comes the genius part. The network uses that error signal to work backwards through all its connections and slightly tweak all those little weight dials. A connection that contributed to the wrong answer gets turned down just a tiny bit. A connection that might have helped gets turned up. And then you just repeat. You do this millions of times, and with each little adjustment, the network gets a tiny bit smarter, until eventually its guesses are incredibly accurate.
Now, I know this can all sound super abstract and techy, but I promise you, you are interacting with neural networks every single day. Let's just look at a few places where they pop up. Every time your phone tags your friends in a photo automatically, that's a neural network. When Google Translate gives you a real-time translation, that's a massive network that's learned the patterns of human language. Those recommendation engines on Netflix or Amazon that know exactly what you want to watch or buy next, you guessed it. From self-driving cars learning to see the road, to doctors using them to spot patterns in medical scans, these things are absolutely everywhere. So, look, if you remember just one single thing from this entire explainer, please let it be this. Traditional software is built on rules that humans write. A neural network is fundamentally different. We don't give it the rules. We give it the data, and it figures out the rules all by itself. And that means we can use them to solve problems where we don't even know what the rules are to begin with.
And that really leads us to the final, most exciting question of all. We've built a machine that can learn from experience. We've already taught it how to see, how to write, how to translate languages. So the only real question left is, what on earth are we going to teach it to do next?